In furtherance of the drive to provide indigenous solutions to tackle the COVID-19 pandemic, the Nigerian Air Force has unveiled 2 emergency ventilators produced by a team of researchers from the Air Force Research and Development Center and Air Force Institute of Technology, Kaduna, in partnership with the Faculty of Veterinary Medicine, Ahmadu Bello University, Zaria, and the Department of Mechatronics, Federal University of Technology, Minna. The emergency ventilators tagged unveiled were unveiled on the 27th of May 2020 by the Chief of the Air Staff, Air Marshal Sadiq Baba Abubakar, in Kaduna. Before the unveiling ceremony, the prototype event had been subjected to successful animal testing using the canine and the porcine as test subject.
The first phase was to test the durability, and the second phase was to look at the efficacy vis-a-vis the conditions we are thinking about at this time. Let's test it on an intact animal. Will it work? If not, what ought to be done? Then we began to look at some other conditions. Apart from being an intact animal, what if we have a condition where the lungs of the patient is paralyzed, the patient comes unconscious? How will this machine help? Then another thing we thought of is, okay, not only that, we are talking about COVID here. The patient may not be unconscious, but is having difficulty with the respiratory system. So can this machine cope with this? So we thought, okay, to do that, let's take 2 animal models. So we said, okay, let's use the canine, that is the dog, and then we said we use the porcine, that is the pig. Using the canine, we tested the durability and the intact animal. Also on the pigs, we tested the intact pig and then a pig that has a condition that simulates a COVID condition. Taking parameters, physiologic parameters that are just normal. The physiologic basic parameters, the cardiac responses, the respiratory responses, even the neurophysiologic responses of these animals while the animal is placed on the machine. And surprising, if you talk about the neurophysiologic responses, it was wonderful. I am not with the tracings now. When we talk about the cardiac responses, the heart, how it responds to patients on this machine, especially when we're talking about having paralyzed the respiratory muscles, or when we're talking about a condition that represents a COVID condition, when we decide to induce an acute lung injury and acute respiratory distress syndrome, we discovered that the heart was just wonderful.
The successful testing of the canine and the porcine subject concluded the animal test phase of the events project. The Nigerian Air Force team had also repaired some existing faulty imported ventilators and developed infrared thermometers. The Nigerian Air Force events were compared with the repaired ventilators and found to deliver similar performance in air volume control and assist control modes. The tests were also necessary to validate the effectiveness of the assist ventilation mode, where the ventilator detects a breath from a patient being treated and synchronizes the equipment with the patient's breathing. The Nigerian Air Force events are intended for use when conventional invasive respiratory support resources have been exhausted. In the Chief of the Air Staff's quest to contribute towards self-reliance in the battle against COVID-19, a team comprising Nigerian Air Force personnel and researchers from partner institutions were convened to research into the production of the emergency ventilators. The team commenced work in early April 2020 and within 3 weeks had developed 2 prototypes. Having seen the progress made, it became necessary for the prototypes to undergo animal testing to ascertain their capacity for use on patients with respiratory illness. Leader of the Nigerian Air Force Research and Development Team, Group Captain Osichinaka Obadike, gave details of the development process.
We have different teams. We have the hardware team, we have the software team. The hardware team were in charge of developing the physical components, while the software team were involved in developing the software. And there's now an integration team that integrated both the hardware and the software, as well as the mechanical components of the ventilators. The two ventilators have different modes of operation. The small ventilator uses a servo motor, while the big ventilator uses a windshield wiper motor. So controlling this motor, especially the windshield wiper motor, is very tricky because it requires very small movement to press the ambu bag to generate the air. Then apart from that also, there are some sensing. There's a pressure sensor that senses the volume of air coming out and the pressure of that air and feeds that back. It's a closed loop system because you want to deliver a certain volume or a certain pressure. So when you are delivering a certain pressure, you want to sense the pressure coming out, and then your control algorithm will be able to tell the machine to stop once the desired pressure is reached. And also for the volume, you want to develop a particular volume. So we develop some of those components locally. For instance, the flow meter that detects the volume of air that goes out of the system, the sensor was developed locally, and from there the software will now convert that measurement to a volume and display it on the equipment.
Present at the unveiling ceremony were the Chief of Standards and Evaluation, AVM Remigius AK, Chief of Medical Services, Air Commodore Gideon Bako, and directors from Headquarters Nigerian Air Force, representative of Vice Chancellor ABU Zaria, the Dean of Faculty of Veterinary Medicine of the University, Professor Jacob Kwaga, the Commandant Air Force Institute of Technology, AVM Abdul Ganiu Olabisi, as well as commanders of co-located Nigerian Air Force units in Kaduna. Nigerian Air Force, willing, able, ready.